Okay, we just got done converting between rectangular coordinates and polar coordinates. So let's take that concept and apply it to converting equations from one kind to the other. So let's start with converting polar into rectangular and see what we come up with. So for example, we take r is equal to 3 times sine of theta. So think about what we have to work with. We have that x is equal to r cosine theta, y is equal to r sine theta. Okay, that's part of it. We know, let's see, x squared plus y squared is equal to r squared, and the tangent of theta is y over x. So surely we can do something to make the conversion. Now, what I recommend that you do is memorize the things that we have here in red. Use those guys and know how to manipulate them. For example, I don't have anything where it's just r, right? I don't have something where I can easily convert r and theta together. But I do have sine of theta right here, and I have this statement right here that y equals r times sine of theta, which means that from here I can say that sine of theta is y over r, which we already know, right? So then this equation becomes y is equal to 3. We rewrite sine of theta as y over r. So we're almost there. The next part is to multiply both sides of the equation times r, and that just helps us clear out the denominator. So r squared is equal to 3y. Okay, we're almost done. We still have r, but we need to convert that r into x and y. And look at the thing that's in the upper right-hand corner. R squared is x squared plus y squared. So we've converted. Now, depending on what you're working with, they may want you to go a little bit further than this. So you could just bring everything over to one side like this so that it equals 0. And we could say that it's done. Now, with experience, we should be able to look at this and see that this is the equation for a circle. So if you go about the process of completing the square, which I'm not asking you to do just yet, you would have x squared plus y minus 3 halves squared is equal to 9/4. Okay, again, I'm not asking you to do that, but we can see here that we would have a circle that is centered at 0, positive 3 halves, with a radius of 3 halves. Again, more than likely this is all that you would need to do, but just be prepared to go the extra step. All right, let's look at this next one. So for the next one, we have r equals 4. Now this one is actually quite simple, but it requires a bit of a trick. So one of the things that we can do is that we can multiply both sides times r. So we have r squared is equal to 4r. And just like the previous example, we know that we can rewrite r squared as x squared plus y squared. But what about that extra r that's over there? Well, the weird thing about this is that at the very beginning, they told you that r equals 4. So if I plug 4 in for r, that's going to be valid because they defined r to be equal to 4. So by making that replacement, we have x squared plus y squared equals 4 times 4, which is 16. And you're done. Not anything else to do there. This is clearly a circle with a center of 0, 0, and a radius of 4. Oh, you mean like how it said r equals 4 at the very beginning? Yeah, that's exactly what I mean. Because if r equals 4, it doesn't matter what the theta is. If you were to draw this, your distance from the center, from the pole, is going to be 4 units. So it would be 4 all the way around, which creates a circle. Boom. Isn't that great? Love it. All right, so r is equal to 4 cosine theta minus 10 sine theta. Now this one's going to be very similar to the first one that we had in this video. You know how I rewrote sine using the XYR definition as being y over r? Let's do that for sine again and for cosine. So r is equal to 4. Cosine becomes x over r minus 10. Sine becomes y over r. And as we did in the first problem in this video, let's multiply everything here times r so that we can clear up the fractions. So we have r squared on the left, 4x minus 10y on the right. Because this r right here is going to reduce with each of those denominators. That's why we chose it. And again, r squared is equal to x squared plus y squared. So there we go. We're not in r and theta anymore. We're back to x and y. Now let's clean this up. Let's make sure that we get good practice here. Let me move the 4x over as a minus 4x. I'm going to intentionally leave some space. Then we have y squared. We add 10y, leave some space, and we have 0 on the other side. Now, without the gaps there, you could probably type this into my math admin and say, huzzah, good job, excellent. But what I want us to do is I want us to complete the squares on this so that we can see what our circle really looks like. So for the x, to complete the square, we take half of this coefficient and that goes in the factorization. So minus 2. But that minus 2 would mean that we would complete the gap here with a plus 4. Now I can't just add 4 on one side of the equation because that would change the problem, unless I also add 4 on the other side. Similarly, when I look at the y, to figure out the factorization, I do half of 10, so that's 5, and 5 squared is 25, and that's the number that completes the square for that. And again, you have to add that to the other side, otherwise you have broken the equality that we had established from the very beginning. 0 plus 4 plus 25 is 29. So all the stuff that they gave us for r equals 4 cosine theta minus 10 sine theta, that graph is really just the graph of a circle with a center of 2, -5, and a radius of the square root of 29. Yeah. So there you go. Conversion really isn't so bad. You just have to remember some of the tricks. Remember that when you see r squared, you're going to rewrite that as x squared plus y squared. Easily converting from r into x and y. And then, of course, the simple trick of cosine of theta is x over r, and sine of theta is y over r. All right, so keep that straight, and you're going to be okay.